Does a case really matter? How much of a difference does a case make when you drop your phone? Well, let's test it. And if you're a test engineer, this video is for you because I'm gonna build the whole system right now. For hardware, I've got my CompactDAQ data acquisition system with a module specifically designed for accelerometers. This specific one can measure over 100,000 times per second, but we actually have a more entry-level version that would sample at 12,000 times per second, which would be great for this application as well. I also have a tri-axial accelerometer that I borrowed from our packaging lab. Thanks, y'all. I've already dipped it in some accelerometer wax, so I'm just gonna go ahead and adhere it to my test phone. And that should survive the drop. Okay. Now, let's switch over to software, and I'm gonna configure FlexLogger to trigger on this drop test. It's already detected my hardware, so I can double click on a channel, and this is gonna be the x-axis. It is an accelerometer, so I'm gonna choose acceleration. And it's an IEP class sensor, which really just sets the standard for what kind of power this accelerometer needs. For sensitivity, you get that from the data sheet, or in this case, I've got it on the calibration sticker on the sensor, and there's one for each axis. And so the x-axis is 9.52 millivolts per G. And I'm gonna look at my configuration pane and hit this little auto config for a sanity check. There we go. And so I can see data, looks like it works, everything's good. So I'm gonna hit done, and that's it. I've just configured one of the axes. Now, from working with the packaging lab, I've learned that dropping a filter on the accelerometer data is really helpful. So I'm gonna add a calculated channel, and I'm gonna select that x-axis channel that I just configured, and I'm gonna set this to 500 hertz low pass. And same thing, I have the configuration pane, so I can do a sanity check, and so that looks even smoother than it did before because it's gotten rid of all of the noise above 500 hertz. Great, so I'm gonna hit done. At this point in time, I'm actually gonna scoot forward because you don't need to see me copy paste this times 3. So give me a second to configure this and I'll be right back. Okay, let me walk you through what I've configured in this FlexLogger project. I now have X, Y, and Z axes all configured with the sensitivities from the calibration sheet. I've created I've copy pasted a filter channel for each one of those. So I have an X, Y, and Z filter with a 500 hertz low pass. And then I added a trigger channel, which is the summation of the X, Y, and Z filter channels. And all that does is show me just the data I care about. So I'm gonna trigger on any impact greater than 10 Gs, and I'm gonna take the half a second before and 1 second after. That's all the data that I'll look at. It just kind of cleans it up for me. I set the trigger in this logging specifications tab, which is where, scroll down here, I said, hey, trigger on a value change of this trigger channel that I created, anything over 10. And then there's the half second before and the 1 second after. And with that, we're ready to start dropping. So I'm gonna go ahead and click run, and it's gonna ask me, hey, is this case or no case? I'm gonna start with no case. So it's gonna be the unprotected drop. And now my trigger is armed. And so anytime we see more than 10 Gs, we're gonna trigger and capture data. All right, let's drop this from the standard height of 1 NI box. Ooh, that sounded painful. Okay. I'm gonna pause my data. Now all that data has been recorded into a digital file, an open binary file, but I can still look at it live on the screen here and interact with it. So the x-axis took the brunt of it at 187 Gs of impact. So let's unpause and gonna put the case on real quick. So we put the case on. And I'm gonna say, okay, this data set, case equals yes, and this is just gonna help me with some metadata if I wanna go back and evaluate. Okay, so the trigger is armed. I'm gonna do the exact same thing. Standard height, 1 NI box, but this time with a case. All right, gonna pause. So right away, I didn't change the scale at all, so you can see that the data on the same scale shows a significant attenuation in impact. So even that really thin case, which is kind of like a hard leather case, nothing fancy, made an impact on the impact. So this maxed out at about 130 Gs, so shaved quite a bit of G-force off of that impact. Now, if you want to set up a system like this on your own, I used the 9232 module. The 9230 is the one that runs at 12 kilohertz, and that's a much more entry-level price. And actually, when I ran this FlexLogger, I was running it at 12 kilohertz, so what you saw is what you could get with that entry-level module. And then also you'll need a chassis. I used a 4-slot chassis here, which is great if you want to add temperature or voltage or some kind of digital trigger. That can go into the chassis as well, but we also have 1-slot chassis available. All right, so thanks for watching, and drop it like it's hot.